The Vernier caliper is one of the earliest and most versatile measuring instruments available. It's a simple tool, and yet it is capable of accurate measurement to within approximately 0.02 of a millimeter, if used properly and looked after. The measurement principle has been used in a wide range of applications, from the familiar caliper to the gear tooth vernier, a related instrument, and the vernier depth gauge. The vernier height gauge can be used for both measurement and marking out. The vernier protractor can measure angles to within 5 minutes of arc. Even a micrometer has its resolution increased with the addition of a vernier scale. Machine tools have vernier scales built into them to enable accurate setting up with maximum ease. There are many different scales used on the various machines and measuring instruments which incorporate the vernier principle. However, they are all developed from the same simple concept. This scale is marked with 10 equal divisions for each numbered unit. The size of each unit does not matter for this explanation. So we have a scale which will allow us to read a measurement in units and tenths of a unit. Now we add a vernier scale, which is slightly smaller than one main scale unit. In fact, it's equal to 9/10 of a main scale unit, but it's divided into 10 equal parts. So each vernier scale division has a value equal to 1/10 of 9 main scale divisions. In other words, each vernier division is 1/10 less than its corresponding main scale division. If we do our sums now, we can see that this small difference is equal to 1/10 of 1/10 of a main scale unit, which is 1/100th of a unit. When we move the vernier scale, each division lines up in turn, adding 1/100th of a unit at a time to the reading. To read this particular scale then, we note how far along the main scale the vernier 0 has travelled in units and tenths of a unit. Any further part of a division is read from the vernier scale. In this instance, the 6th vernier mark lines up, and so we add 6/100ths or 0.06 to the reading. The metric vernier caliper uses the very same principle that we've just looked at, except that the scales are different. The main scale is marked in centimeters and millimeters. The vernier scale is made equal to 49 millimeters, but is divided into 50 parts. Now this means that one vernier division is equal to 1/50th of 49 millimeters. So it's equal to 0.98 of a millimeter. You can see now that each vernier division is 0.02 millimeters less than the corresponding main scale division. To get the vernier reading, we add the number of 0.02s up to the coinciding lines. This is made easier because each fifth line is marked. In this example, the vernier 0 has passed 47 millimeters and a little bit. The little bit we read on the vernier scale, which shows 0.5 millimeters and 0.06 millimeters to the coinciding lines, giving a total of 47.56 millimeters. By now, you'll have the idea that vernier scales are basically similar, and they are. You will be able to read any vernier if you follow this procedure. Work out the number of main scale divisions spanned by the vernier scale. Then divide this number by the number of vernier scale divisions. The result will be the value of one vernier division. The difference between one vernier scale division and one main scale division will equal the smallest vernier scale increment. If you can work all of that out, then reading any vernier is simply a matter of reading the main scale to the left of the zero and adding the vernier scale reading. You'll be feeling pretty confident by now, so let's have a look at a few more examples. Try working out this one. Okay, you should have got 72.48 millimeters. That is 72 millimeters from the main scale, 0.4 millimeters from the marked vernier scale, and a further 0.08 up to the coinciding lines. What about trying this one? Did you get 27.94 millimeters? If not, well, perhaps you need a little more practice. Let's try another one. .12 millimeters. Not so difficult, was it? Well, that's the vernier caliper for you. Not much of a mystery, just a good basic measuring concept packaged in an easy-to-use instrument with wide applications. Perhaps it's worth having a closer look at a few of the variations that have been produced for the vernier scale. There are two fairly common types. The short scale vernier, where the vernier sits across 39 millimeters, and the long scale vernier, where the vernier scale spans 49 millimeters. There may be other variations within each type, usually to do with the numbering of the vernier scale. But remember what we said earlier about working out the value of the main scale and vernier scale divisions, which when subtracted one from the other will give the value of the smallest vernier increment. Now, we had a quick look at the gear tooth vernier earlier, but it might help you if I show you briefly how it is used. In fact, it's really two verniers in one. This scale is used to set the corrected addendum of the gear tooth, and this scale is used to measure the caudal thickness, which has to agree with specifications. It looks pretty involved, but it's really pretty simple. And this unit's pretty simple too. In fact, it's not a vernier at all. It's a caliper with a dial readout to give you the same degree of accuracy with easier reading. Again, just be sure that you know what each dial division represents. The vernier protractor should not present any problems for you in its reading if you think of it as just a curved vernier. The vernier 0, again, indicates the number of whole main scale divisions, degrees in this case. The vernier scale has 12 divisions, each representing 5 minutes of arc. So, a complete reading would be made up of the number of whole degrees up to the 0. Plus the number of minutes shown by the coinciding lines on this vernier scale. It's important that you use the vernier scale which follows on in the same direction as your main scale reading. If you want to check the value of each vernier division, use the method I described earlier, just to be sure.